Hi, welcome back to our Intro to Functions and Function Notation, the third part. Remember, this is a very fun topic, and I hope that you enjoy today learning about composite functions. But before we get into that, first of all, let's review where we've been so far. This topic comes out of Chapter 1, and if you look at the beginning of the textbook, chapter, you will see that there are a list of things that you should be learning in this chapter. And so this section, it has listed all the different things that you'll be learning. And so far, we should be familiar with the terms function, domain, and range, and also the ideas of many-to-one functions or one-to-many. One-to-many is not a function, but one-to-one functions. We also started to talk about how to use notation and how f bracket x bracket and then equals something is a way of expressing a function of x such that 2x cubed plus 5 is what is being calculated. And we have seen arrow notation, and we have started to be able to explain in words why a given function is a function or why it isn't and what restrictions it might need. Before you carry on with composite functions, your teacher may also have you do some work from 1.1 in your textbook, which talks about mappings. And just to note, it uses the arrow notation. It has a good review there of what is one-to-one, many-to-one, or one-to-many relationships, and which ones are functions comes up. Then just in the notation, note that if it does say a function of x such that x plus 1 is the function, and then if it has something like x is an element of R, that means of real numbers. If it has something else after that, usually that's the restriction on the domain. So in the case of the example on the screen here, if x has to be greater than 0, then you can't put in any values for x which would be equal to 0 or less than 0. When you get into, you should be ready to do any of the questions from that section. When you get into section 1.2, you'll notice that they again give a definition of a function. Now, in our first few lessons, we talked about a function being a mathematical relationship that uniquely maps a set of numbers onto another set of numbers. In the textbook, section 1.2, it says a function is a rule that maps each x value to just one y value for a defined set of input values. This is basically the same thing, because you note that uniquely means just one. So there's just one x value. Each x value has just one y value. So it's the y values that there can't be more than one. So we talked about the vertical line test. And you should be able to do any questions now from section exercise 1.2 also. And this notes again that one-to-one or many-to-one relationships are functions, but not one-to-many or many-to-many. When you're doing the questions from 1.2, they restrict the domain. So they say, okay, I have a function of x that equals, for example, x minus 5. But what is the range if x can only be from minus 2 to 7? So what you have to do is you calculate. You stick in, well, if it's minus 2, then it must be as low as minus 7. If you put in 7, it'll be as high as 2. And so that gives me the up and down of the outputs, which is the range of a function. So the important thing to make it a function is that when you get an output, there can only be one output. You can't get two outputs or have it be ambiguous what the output is. So as we go on today and talk about composite functions, where is that in our initial targets for the chapter, you can see that the first line talks about understanding the composition of functions. And what do you do if you have f squared bracket x bracket? So those are the two things that will be more clear after today's lesson, hopefully. Our outcome is that we will start to understand the basics of notation for composite functions and how to notate them and how to find their values. And we might be finding their values as a number, or we might be finding their values by expressing the composite function in a simpler way algebraically. All right, first of all, what is a composite function? When we were talking about functions, we said that functions are sometimes written as f of x, but they could be written g of x or h of x, and they might be different functions, and that different letters representing different functions by different letters allows us to compare these functions and do things with them together as we carry on. When we started to talk about a function, we said it's a little bit like a machine with a slot in it. And we stick values through the machine and different values come out the other side. Well, a composite function is something that combines two or more functions. So you might end up with a composite function that's like way up in the left, top left corner, gf of x. Well, what does that mean? If you have more than one function, what you have to know is which one do I do first? And then what do I do after that? So if you have a function that's just simple f of x, where you're multiplying, f of x is equal to 2x. Then minus 1, when it would go through, would be minus 2. 0 would become 0. 2 multiplied by 2 will be 4. If I have two functions, I do the one that's closest to the x first, and then I do the next one to the outputs that I got from the first function. Here's a visualization of it. If I have something like gf of x, imagine I'm putting, first of all, those first values, I'm putting them first through the number one little machine, the green one. And I'm putting these values through and I'm getting the outputs that we said on the last screen. Then with these outputs, I'm sticking those through another function. If I put them through another function, g of x, and that was 3x plus 5, if you put minus 2 through, and 0 through, and 4 through that little slot, you're going to end up with these values. Your textbook has a little diagram under section 1.3 of composite functions. It's on page 5 if you want to turn in your textbook and look at that. I find the diagram a little bit hard to read at first, but if you read the pink box, it helps to explain it. It says fg of x means the function g acts on x first, and then f acts on the result. So as you're going along, first you have the x, and then you do the action of g, and after that you do the action of f. And so fg of x, first you do g, then you do f. And the order is important, so that's why they diagram it and help you to see that the thing that's closest to the x, that happens first, and the output of that becomes the input to the next function. So what is a composite function? It is this process of combining two or more functions into a single function. So if you had it the opposite way, no, this is what we've talked about, sorry. Gf of x is the combination of f and g. The output from f is the input for g. Sometimes you will see a composite function that's doing the same function a second time. If you see that, it will look like a repeated letter, like ff of x. In that case, you're just doing the same function, but repeating it more than once. So for example, you'd run these values through. Say we changed f of x to be 3x plus 5. If you ran these values through, you'd get 2, 5, 11. Then if you ran those original results back through the same function again, and you took 2 times 3 plus 5, you'd get 11. 5 times 3 plus 5, you'd get 20. And 11 times 3 plus 5, you'd get 38. Sometimes you'll also see that notated as f squared of x. It's not really that you're actually multiplying them together. It's just the notation to say I'm doing f 2 times. The function f is happening twice. Once x goes in, and then the output of that is going through the function again. Okay, let's take a minute and see if we understand what we've heard so far. Just look up at the screen, and there are 2 questions, and you're going to see if you can evaluate both questions and try to come up with an answer for them. So you have 2 questions. One is fg of x, fgh of x, and fff of x are all examples of what? You get to take one correct answer there. And then the second one gives you 2 different functions, and then it asks you what would be gf of 11. So this is a little bit of a challenge, but pause the video and see if you can come up with an answer. When you're ready, your teacher can start the video again. So pause it here. Okay, welcome back. So what we want to do now is we want to talk about these 2 questions. Hopefully for the first one, you can see that these 3 things are all examples of composite functions. Now, as you're working out the second one, what you needed to do is first of all think of, well, what if I put 11 into the function f of x? I would get 7 times 11 gives me 77, minus 4 gives me 73. Then I put that answer, that value, 73, into g of x. And I take 3 times 73, and I get 219. If you got that answer, wonderful. If you didn't, don't worry. We'll practice some more, and they'll become more familiar. In fact, let's practice right now and try another one. If I have something like f of x equals 4x and g of x equals 6x plus 3, well, what's then f of 5? What you do then is put 5 into x there, and you find that 4 times 5 is 20, right? Well, we can also evaluate gf of 5. And for gf of 5, the output of f of 5 is then substituted into the function g. So let's see how that goes. If I put f of 5 into g, well, f of 5 we figured out above, the value of that is 20. So what happens if I put 20 into the function g? Well, I get 6 times 20 plus 3. Oh, that gives me 123. Let's try just again another thing here that you can try to see if you can understand what you do first. If I have another function, f of x this time is 7x, and g of x is 2x minus 6. What would it be if I have fg of 3? What does that mean? What do I do? Take a minute to see if you can find from the boxes down below that have dotted lines in purple, what would I put into these 4 blanks? Which things would I fill in the blanks with? If I have fg of 3 and if I have gf of 9, what does that actually mean? You can pause the video, and then when you're ready, you can go forward. Okay, let's see if we got the same answers. If you have fg of 3, the output of g of 3 is substituted into the function f of x. That's what it means. On the other hand, if you had gf of 9, the output of f of 9 is substituted into the function g of x. Hopefully that's starting to be clear. Sometimes you'll get asked, instead of putting the number into a function, you'll be asked to figure out what was the number that went in if I get a certain number out. Let's look at an example. So if I'm given what the function output is and asked to find the input, I'm suddenly being asked to find what was that original x? What was that original card I stuck into the machine? So if f of x equals 4x and g of x equals 6x plus 3, and I'm told that f of x is 40, what would x be? Want to share your ideas? You can pause the video if you want before we show the answer. What would x be? Well, it must be that x is 10 because 4x would be 40, so x must be 10. You can also do this with a composite function. So you might be asked, well, what is x in this case? What if gf of x is 27? How do I think about that? This is important for some of the questions that you'll run into. How do I do it? First of all, you think about it in steps. If g of f of x means that the outcome of f of x is going to run through the function g. So after both of those things happen, it equals 27. So before that, there must have been 6 times something plus 3 that gave me 27. Well, that's actually like an equation. 6 times something plus 3 gave me 27. So 27 minus 3 is 24. So 6x must equal 24. Oh, so f of x must be 4. And if f of x is 4, then x must be 1. Let's look at an example of two students. We'll call them Laura and Lucas. And they're discussing composite function notation. Maybe they have a question which is similar to your questions. Laura thinks this. She says in algebra, AB means A times B. And I know that that's the same as B times A. So maybe FG of x would be the same thing as GF of x, wouldn't it? Well, Lucas is talking to her, and Lucas has a different idea. He says, well, I think, Laura, that yes, A times B is equivalent to B times A, but with FG of x and GF of x, this is function notation. This isn't multiplying. So it's different. And FG of x is the function f of x happening to the output of g of x. Oh, Laura says, okay, so then gf of x is the function g happening to the output of f of x. And Lucas says, yeah, that's it. Well done. I think we're getting this. I hope you're getting it too. Let's see a few more things. One of the things that is important to realize here in what Laura and Lucas were discussing is that switching around a composite function, they're not necessarily the same things. FG of x and GF of x in most cases would not be equal. The only times that they're equal to each other is if the two functions are exactly the same. Then FG of x would equal GF of x because you'd have exactly the same function and you'd just be turning it around. The other time they're identical is if one function is the inverse of the other function. Then the inverse of x times g, f inverse g of x would equal gf f inverse of x. But we haven't learned what an inverse is yet. So don't worry about that for now. Just know that most of the time, fg of x and gf of x won't be the same. Okay, so look at this question on the screen, and you can look at it and pause the video. Fg of x equals gf of x, always, sometimes, never. What do you think? Okay, hopefully you said sometimes. That's what you should say, because they're typically not the same thing, but we just talked about two exceptions. They would be the same if the two functions were identical, or if one was the inverse of the other. All right, let's carry forward. Sometimes in composite functions, you'll see not only two functions, but you'll see more than two functions. For example, here we might have f of x, g of x, and h of x, and then be asked to evaluate, well, what is f, g, h of 4? How do we do this? It's the same process, but you just work from the inside. The first thing that you need to do, maybe you should try it. Pause the video and try it. Okay, welcome back. In this function, if you took h of 4, then you put it into g of x. And then that output you put into f of x. So what is h of 4? Let's see. If we calculate that up at the top there, if I put 4 in, I get 3 times 4, which is 12, minus 7 gives me 5. So that value is 5. Now I need to put 5 into the function g. If I do that, then I have to figure out g of 5. Well, what is g of 5? G of 5 is going to be 5 times 5, or 25. Then that value is my input into the next function out. So I put that into f of x. If I put that output, 25, into f, what do I get? I get 2 times 25, which gives me 50. One more question for you to try. This one I think you will want to pause a little bit and give yourself time to look at it and ponder. If you had these three functions and then you were asked to evaluate the composite function GHF of 5, which one of these would be the correct working? So I recommend again that you pause the video here and see if you can think of which one you think is the correct answer. Okay, hope you shared your answers, what you think. Let's check and see what is the answer. Okay, if you got C, you're correct, because what you want to do is first evaluate f of 5, and that answer of that would be 5 plus 10, which means it would be 15. That's the input then into h of x. So I put 2 times 15, and I subtract 9, so I would get 21. And then this would be the input into g of x. Earlier, we said that you can also sometimes see composite functions, which is a repetition of the same function. Let's look at that with a few numbers instead of just looking at it with the pictures of the little machine. If you have something like f of x is 5x plus 3, and you're asked to evaluate f of 2, hopefully now you know that you put that in and you say 5 times 2 plus 3. So how much would it be? If you said 13, you're right. 5 times 2 plus 3. What would happen then if I say I want ff of 2? I need to take that output of doing it one time, the output was 13, and I need to apply the function f to that again. In this case, the output goes back into the same function, goes back into f another time. So you put f of 13, and then you find out, oh, if I run 5 times 13 plus 3, I get 68. What if you do this one more time? How many times you do it, it actually doesn't really have a limit, although normally you won't see it too many times. If I did it 3 times, then I would take that value 68 that I already have from ff of 2. So we know that this was ff of 2 from our second line of working. So we put that back into the function one more time. If you put 5 times 68 plus 3, then you get 343. Sometimes you'll see this shortened to f squared of 2 or f cubed of 2, but that's what it means. It means you repeat that function 2 times or 3 times. Okay, what if we have functions that are a little bit more complicated? Here we have Laura and Lucas again discussing 2 other functions. We have f of x, which is x squared minus x, and we have g of x, which is x plus 5. What do we do if we're asked to find fg of x? How can we make it a little bit simpler? Well, Laura thinks if I take g of x output and I put that into f of x, I could do that by taking what is g, x plus 5, and putting that into f of x. So I would then say x plus 5 squared minus x plus 5. Each place where the x is, I put the value in. So Lucas says, well, couldn't we expand and simplify that? And here's how he did it. He put those values in, and then he multiplied them out. Remember, we know how to multiply x plus 5 all squared. We get 3 terms, x squared plus 10x plus 25. And then they've simplified it at the end. And what I want you to look at is, what do you think about what Laura and Lucas have done? Do you agree with it? Well, what they've done is true. You can simplify the algebra before you substitute into it. So you're allowed to expand and simplify. And they're correct in what they substituted in. That was fine, but there's a problem in this last line. What is that problem? The problem is that they forgot that the negative applies to both the x and to the 5. And so they ended up with 25 plus 5 making 30 instead of 25 minus 5 making how much? That's our problem right there. It should be, we have to subtract both terms, says Laura, inside the bracket. And Lucas does some calculating and says, oh, of course. So it should have been minus 5 as well as minus x. And if you have 25 minus 5, I get positive 20, not positive 30. Hopefully that makes sense to you. You can have a look at it if it doesn't. And that is the correct answer. So you can simplify things or write them, a composite function, you can write them algebraically, putting the 2 functions together. Here are some things to try. Here are 2 other composite functions, very similar to what we just did. Pause the video, grab your notebook, and see if you can figure out which one is the correct answer for the composite function fg of x. Pause. Okay, you should have gotten the last one, part C, because the calculation is that you take x plus 2 and you square it, and then you subtract x plus 2 all in a bracket. And that then is the next line, which is then simplified down to x squared plus 3x plus 2. Okay, how about this one? Try one more. You can pause the video and see if you can get what is fg of x here. Pause the video. Okay. Move forward. Hopefully in this case, you chose A. That is the answer because you take x plus 4 and you put it into the values where x is in the f of x, and then you expand it, and you remember that that negative is going to apply to all three terms in the bracket, which then gives us minus x squared minus 7x minus 12. Okay, I've given you some exercises to try, which are here on the screen as task B. And you should be getting a handout of this so that you can try. Question number 1 is writing an expression for these composite functions that's similar to what we were just doing. These ones are a little simpler. Then you're going to look at Laura's work. Remember Laura? She's done some work and you're going to be the teacher and you're going to mark her work and see if you agree with it, or if you don't think that there's something, if you think there's something where she's made a mistake, you can mark that and then tell her what she could do to improve or what she did wrong. How can she make it correct? And then the final question is you have some functions that are a little bit more complicated, and you can write what those composite functions would look like if you simplify them algebraically. All right, so you can pause the video and work on that. Either it might be homework or it might be that you do it in class. And when you're ready, then you can proceed with the video. Okay, welcome back. Hopefully you all did task B, and now you're on the stage of correcting it. And you may have already corrected it, or your teacher may have. But if you are still correcting your work as we go through, you can see that fg of x would be equal to 8 bracket x minus 3. Of course, if you did 8x minus 24, that's also fine. If you did gf of x, that would be equal to 8x minus 3. ff of x would be equal to doing 8x and then doing it again as the x, and it becomes 64x. gg of x, and then you would come up with x minus 6. All right, when you were marking Laura's work, hopefully you noticed that she was correct up until this stage. And then what did she do? She forgot that negative times a negative would be a positive, which means her final answer was also not correct. So you may have written something like, you have to subtract both terms inside the bracket. Minus a minus is positive 7, not minus 7. Okay, this is what it should have looked like, and that would have been the final answer. Okay, second one, how did Laura do on this one? She got it right at first, but then she forgot to substitute x minus 7 also into the spot of x. So it leads to an error, and you may have written that x minus 7 is the input for the function, but it should be x minus 7 squared plus x minus 7, and then it would be simplified after that. So it would lead to x squared minus 13x plus 42 instead. All right, that was question number 2. If you're still correcting, question number 3, what is the expression for these composite functions? When you work that one out, it leads to x squared minus x plus 4. And then this one had a little bit more working, but it leads to x squared plus 7x plus 12. And ff of x, when you calculate that out, is x to the 4th power minus 2x to the 3rd power plus x. If you have questions on that, you can pause the video and talk to your in-class teacher about that. Right, after you've done that, you are ready to basically do anything from section 1.3 on composite functions. And your teacher will choose which ones they want you to do based on time, or if they want you to try some for homework. As you look at these questions, notice that these questions again give you practice with arrow notation, and also from question number 7 forward, if you're solving questions that are beyond number 7, you're going to be solving equations. You're finding what is the input that must have gone into this if I got this output. All right, let's summarize and see where we're at. What have we talked about? We said a composite function is a combination of 2 or more functions, and it can be evaluated numerically as well as expressed algebraically. So for example, if you had something like f of x is 9x, g of x is x minus 8, we could evaluate fg of 1 or fg of 2 or any other number, or we could also write and simplify the expression down to 9x minus 72, or if you left it in brackets, 9 bracket x minus 8. All right, that's all for this video. Have a lovely day. Talk to you soon. Bye-bye.